Hello everyone. Today we're going to look at the Poisson distribution. The Poisson distribution is a discrete random variable with the probability of events occurring in a fixed interval, usually time or space. The events must happen with a known average rate and independently of time since the last event. So as an example, the number of words spelled incorrectly in a particular book. Assume we know that on average there are 5 words spelled incorrectly in 100 pages. The interval would be the 100 pages, and x would be the number of occurrences in the interval of interest. X is p of mu, where p stands for Poisson, and mu is the average for the interested interval. And sometimes mu is represented by the Greek letter lambda in some books. So if you see lambda, it's the same thing as mu. So it's the average for the interested interval. Another example is the average number of fish caught in an hour. So we can assume that the average number of fish caught in an hour is 12, and we're interested in the probability that we catch 4 fish in 15 minutes. So the interval of interest in this case is 15 minutes. So we need to find the average number of fish caught in that time frame. There are 15 minutes, that's not really a sentence, but we'll get rid of that. 15 minutes is a quarter of an hour. So 12 divided by 4 is 3. So 3 fish are caught on average every 15 minutes. And this means that x is p of 3. So 3 is the average of the 15 minutes, which is what we want. So we have to make sure that what we're given, which was per hour, we translate that into what we're interested in, which was the 15 minutes. So again, we need to divide it by 4 because there are 4 15-minute intervals in an hour. So what we're really interested in is how to find probabilities, and these are going to be pretty similar to the binomial distribution that we talked about in the binomial section. The probability that x equals x will be Poisson.dist of x comma mu comma 0. So again, x is the number that we're interested in, mu was the average, and 0 is, just like with the binomial, the cumulativeness of this. We don't want it to be cumulative, so we have a 0, because it's just x equals x. If I want x less than or equal to x, then I want a 1 in that last spot for the cumulative. I do want 0 through x. And then the probability that x is greater than or equal to x is, again, 1 minus the probability that x is less than or equal to x minus 1. And again, that's because we're in the discrete case. So again, very similar to the binomial, it's 1 minus Poisson.dist x minus 1 comma mu comma 1. We also talked a little bit about the case of x being between two numbers with the binomial. And again, it's the probability that x is less than or equal to b minus the probability that x is less than or equal to a minus 1. So we have the Poisson.dist of b mu 1 minus Poisson.dist a minus 1 mu 1. So again, very similar to the binomial, just instead of binom, it's Poisson. So for the fish problem, we had that x was p of 3. So we're going to find the following probabilities. What's the probability that x equals 4? So what's the probability that we caught 4 fish in 15 minutes? So I plug in my x is 4, so Poisson.dist of 430, and I get out 0.168031. So if you haven't already, pull up Excel and type this in and make sure you're getting the same numbers. Make sure that you understand what's going on. And again, don't forget that if you want Excel to do anything, you have to start off by putting the equal sign in front of it. So equals Poisson.dist, parentheses 4, 3, 0. Let's find the probability that x is less than or equal to 4, so that we caught at most 4 fish. So that's Poisson.dist 4, 3, 1, which will give us 0.815263. If I wanted the probability that x is greater than or equal to 4, we caught at least 4 fish. then that is 1 minus Poisson.dist of 3, 3, 1. So again, we're going to take away 0 through 3 because we want 4 through infinity. And that will give us 0.352768. And then the last one, what's the probability that we caught between 3 to 5 fish? So if I wanted, I could use this same thing up here and do the probability that x equals 3 plus the probability that x equals 4 plus the probability that x equals 5. There are only 3 numbers that can be here, 3, 4, and 5. So it wouldn't be that difficult if I just wanted to add the 3 together. Or I can use probability of having at least 5 and then at most 5 and subtracting the probability of having at most 2. But just remember that this has to be this guy minus 1. So Poisson.dist of 531 minus Poisson.dist of 231. And we get 0.492892. So let's try another one. Atlanta's Hartsfield-Jackson International Airport is the busiest airport in the world. Tends to be a Jeopardy question. On average, there are 2,500 arrivals and departures each day. How many arrivals and departures, on average, are there each hour? That is the wrong there. That should be there. So we take our 2,500, which is in a day, and we divide it by 24, the number of hours in a day. And we get 104 and a sixth. I can put it as 104 and a sixth in Excel every time I use it, or I can just put in my 2,500 over 24 each time too. But don't round it. Don't call it 104.7. Okay, you want to keep the entire number. B, what is the probability that exactly 100 airplanes arrive or depart in 1 hour? So I want exactly 100. So I'm going to have Poisson.dist 100, 2,500 over 24, and then 0. Remember, 0 is for the exactly. And I get 0.036632. It's very hard to pinpoint the exact amount. So whenever you're looking for the probability that exactly something happens, it tends to be fairly small. What is the probability that there are at most 90 arrivals and departures in the 1 hour? So at most 90 means 0 through 90. So that is Poisson.dist 90, 2,500 over 24, 1. Remember, 1 means I'm going to add up from 0 to x. And that is 0.087975. So again, it's a fairly small amount. We know on average there are over 104. So the fact that we're looking for the probability that there are at most 90, it's going to be fairly small. What is the probability that there are at least 105 arrivals/departures? So at least 105 means the opposite of at most 104. And remember, Excel does less than or equal to or equal to. So 1 minus Poisson.dist 104, 2,500 over 24, 1. And we get 0.480467. E. What is the probability that there are between 85 and 110 arrivals/departures? So we're looking at between two numbers. So we're going to have the difference of them. So Poisson.dist 110, 2,500 over 24, 1, minus Poisson.dist 84, 2,500 over 24, 1. Remember again that I want to keep 85 in there, so I'm subtracting 84, 83, 82, 81 through 0. Okay. And that gives me 0.7117679. We're going to do one more example. This is a very common example for the Poisson distribution. There were 196 deaths over 280 core years. So this means there were 14 cores that we were surveying over 20 years. So 14 times 20 gives us the 280. There were 196 deaths over these core years due to horse kicks in the Prussian army between 1875 and 1894. This is modeled by a Poisson distribution fairly well. And we're going to find the probability of exactly 0, 1, and 2 deaths by horse kick in a single core year. So the first thing we have to do is find mu. So we know there are 196 deaths over 280 core years, and we're interested in a single core year. So I take my 196, divide it by 280, and I get 0.7. So mu is 0.7. So the questions are all about exactly a certain amount of deaths by horse kick. So that means my last number in the Excel command will be 0. So for A, I want Poisson.dis 0, 0.7, 0, the probability that there were no deaths by horse kick in a single core year. And that's almost a half. It's fairly good. B, I want the exactly 1 death by horse kick in a single core year, 0.34761. And then C, 2 deaths by horse kick. So Poisson.dis 2, 0.7, 0. And that gives us 0.121663. And again, these actually very realistically go with the actual number of deaths by horse kick in the Prussian army over this time period. So it's very interesting what you can have following certain probabilities, whether it's the binomial or the Poisson or any of the other ones that we're going to come across. So read through the book, try the homework, and let me know if you have any questions. But good luck.